Hey there, I'm Bowden, a developer advocate here at Firebolt, and welcome back to FireEdge. In this video, we'll be talking about zero-copy cloning. To understand zero-copy clone, we first have to discuss why you'd want to clone a table. So, say we've got a table that exists somewhere in our database with a lot of data we care about. And for some reason, we need a copy of it. Maybe that's because we want a snapshot of this table as it exists at this point in time that we can refer back to for record keeping in months or years. Maybe we even want to do snapshots periodically, where we're making these tables and copies of them every so often to make sure that we have a lineage of where our data transformed. Or perhaps you want to make a backup of your data before you do something like a transformation to write new data to your table. If it's in production, or it's important, or it's serving as a source of truth, you want to be sure before you run your SQL script that you're not going to delete a million rows. That means that you need a backup, and that means that you're going to have to create a backup. And historically, this is done with a create table as select statement, where you create a new table, you select all the data out of your original table, and you write all of it to another table. Now, this can be pretty expensive. You're duplicating the storage, and there's a lot of work being done to read and then ingest all of the data into a new table. It's slow, it's costly, and if your table's massive, it can really run up storage costs as well, which is why it's not so great. So, we can do better than copying all of your data, and that's what zero-copy clone does. It leverages the metadata layer that sits on top of your tables. Metadata contains information about your tables and does a whole lot more, and if you want to learn more about it, you can go read the white paper linked in the description below. For today's purposes, the key thing to know about metadata is that it is a lot smaller than data, and that means that duplicating it is much faster. So, in order to create a clone of this table, rather than copy all of the data, what we can instead do is copy the metadata and have it refer to the data that lies underneath inside the table. These two different metadata instances reference the same data, but they represent two distinct tables that can then diverge in history from here. Copying the metadata is an extremely lightweight, near-instant, pure metadata operation. No data is copied as part of this, and that makes it extremely quick and extremely inexpensive to do. So, let's get rid of this old clone that we don't need anymore, and we can talk about how this works. So the reason this works underneath the hood is that data is stored in what are called tablets. Tablets have no hierarchical understanding of databases or schemas or tables. They're simply chunks of data, and it's the metadata's job to keep track of which tablets belong to which tables. This means that there's no performance degradation or sacrifices when cloning a table with a metadata operation. In fact, there's a performance upside, because if you're using and querying both of these tables, the underlying shared data can be cached one time for this table and doesn't need to be cached again for this table. When it comes time to write data, we'll simply create new tablets that are part of and referenced to by the new metadata. And if we want to delete data, we'll create a deletion vector that only belongs to one of the two table instances. Now, there's two more details worth adding here. The first is that when you clone your table, you're also going to clone the primary indexes and partition keys that belong to the original table, and by default, the aggregating indexes will come along too. The other thing is that these two tables are as performant as any other table in your database. We optimize them just as much as any other table, and they will behave and be queried just as efficiently as if the clone operation had never happened at all. This does mean that over time, optimizations such as vacuum operations may duplicate a small amount of the data that was originally shared within these tables as the tablets are consolidated. Let's try this out in Firebolt. I've loaded up our e-commerce sample dataset, which is about 60 gigabytes of data. If you want to try it for yourself, you can find a link to this dataset in the description. The first thing I'm going to do is run the old school create table as select means of duplicating a table. I'll run this query, and Firebolt will immediately begin scanning this e-commerce table and then ingesting this data into a copy of that table. While this is running, we can go over to our zero-copy clone script. This will not duplicate any data. It's going to do that pure metadata operation, so it will reduce storage costs, and if we run it, you'll see it happens in 0.14 seconds, faster than the blink of an eye. This is the difference between these two operations, and when you're trying to duplicate a table, this is why zero-copy clone is a massive improvement. The create table as select took about 25 seconds to finish running, and we can confirm that these two tables that we've created refer to the same amount of data. They both reference 411 million rows. It's the same data, it's two different tables. One duplicated the data, one didn't. Now, let's raise the stakes a little and show off two more facets of zero-copy cloning. The first is how it scales. Instead of a 60 gigabyte dataset like we were using in the last demo, I've created a table that has 60 terabytes of data. This is hundreds of billions of rows. It is a lot of data. I'm using a single small node engine, the smallest possible engine you can get in Firebolt, to do this demo. The other thing that I want to show off is that we can use zero-copy cloning to copy data from one database to another database. So in our FireEdge database, you can see my large table. This is the 60 terabyte table. And in the FireEdge other database, you can see that we don't have any tables at all. Now, I'm going to run the zero-copy clone. This will take a little bit more time as the data set grows because there's more metadata to represent that data set. But as you can see, this only took 5 seconds relative to the many hours it would take for an engine this small to copy this data with a create table as select statement. And we can confirm that this has been copied by going and checking out our information schema for this new table. And you can see it is the exact same amount of data that's been copied over from one database to another. For reference documentation and more information, we have a link in the description to the Firebolt docs on zero-copy cloning. If you want to try it out for yourself, you can get started with $200 in free credits in Firebolt today, and the link to that sign up is in the description as well. Thanks for watching.